Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, my dear students. Hearty welcome to special conference class. Today we are going to learn some more points on Legende's polynomials. Determine the first few Legende's polynomials. Legendre polynomial of degree n is defined by Pn of x equal to 1 into 3 into 5 into etc. 2n minus 1 divided by n into x power n minus n into n minus 1 divided by 2 into 2n minus 1 times x to the power of n minus 2 plus n into n minus 1 into n minus 2 into n minus 3 all divided by 2 into 4 into 2n minus 1 into 2n minus 3 times x to the power of n minus 1. Now putting n equal to 0, 1, 2, 3, we get p naught of x equal to. So here we get n equal to 0. So p naught of x becomes x power 0 divided by 0 factorial, that is equal to 1. p1 of x, that means put n equal to 1, that becomes 1 into x power 1 divided by 1 factorial, that is equal to p1 of x, which is nothing but x, the identity function. Similarly, p2 of x, that is nothing but 1 into 3 divided by 2 factorial times x square minus 2 minus 1 divided by 2 into 3 into x power 0. So on further simplification, you can see that p2 of x equal to 1 by 2 times 3x square minus 1, we get it. Now, p3 of x we are going to calculate. That means put n equal to 3 in this. It becomes 1 into 3 into 5 divided by 3 factorial times x cube minus 3 into 2 divided by 2 into 5 times x. So further it is equal to, I can see, and further simplified, I can show that that is equal to 1 by 2 times of 5x cubed minus 3x. Now p4 of x, put n equal to 4 in this equation. So in the beginning we have to consider 4 terms, that is 1 into 3 into 5 into 7 divided by 4 factorial times x power 4 minus 4 into 3 divided by 2 into 7 times x square plus 4 into 3 into 2 into 1 divided by 2 into 4 into 7 into 5 times x power 0. That is nothing but 1 by 8 times. We can simplify. I have not given complete details of that. That you have to work it out. Similarly, p5 of x, we can show that that is equal to 1 by 8 times of 63x power 5 minus 70x square plus 15x. This is how we can show the results. Now, if you observe the graph of this function in the last class also I have shown, that is nothing but when n equal to 0, p naught of x equal to 1 and p1 of x equal to x. So here you can see it is a constant polynomial. P naught of x is equal to 1. That shows it is a constant polynomial. P1 of x equal to x, it is an identity function. This divides the first quadrant into it is angular bisector, 45 degrees. It makes with the x-axis. So P1 of x equal to x. Now, this problem, second one, which I am going to explain, is an important one for short answer question. Arthvendra Philip. Hello. Hello. Express 2x cube plus 2x square minus x minus 3 in terms of Legendre's polynomials. Now P naught of x equal to x power 0 by 0 factorial, that is equal to 1. So 1 badiga, we can write that as P naught of x. Now what is P1 of x? We know that that is equal to x. So wherever x appears, we can replace x by P1 of x. Similarly, P2 of x equal to 1 by 2 times of 3x square minus 1. So on further simplification, 3x square minus 1 equal to 2 times of P2x. Therefore, 3x square is equal to 2P2x plus 1. Therefore, x square equal to 2P2x plus 1 divided by 2. You will get it. Sorry, it should be divided by 3. Next, P3 of x equal to 1 by 2 times of 5x cubed minus 3x. Therefore, x cubed can be written as 2p3x plus 3x divided by 5. So now wherever x cube is there, replace x cube by 2p3 of x plus 3x divided by 5. Wherever x square appears, we should write it as 2p2x plus 1 divided by, actually it should be 3, by mistake I have written as 2. So please correct it and simplify. You will get the required answer. Show that p n dash at 1 equal to 1 by 2 times of n into n plus 1. So in order to show this, we know that the Legendre polynomial Pn of x satisfies the Legendre equation. What is the Legendre equation? 1 minus x square times y double dash x minus 2x times y dash x plus n into n plus 1 times y equal to 0. So Pn of x satisfies this equation. So we can write this as 1 minus x square times Pn double dash of x minus 2x times Pn dash of x plus n into n plus 1 times Pn of x equal to 0. Now in this equation, we are going to put x is equal to 1. Why? Because we want to calculate Pn dash at 1. So if we put x is equal to 1 in this equation, this automatically becomes 1 minus 1, that is 0. So 2 into 1, that is minus 2 times Pn dash at 1 plus n into n plus 1 into Pn of 1. And we know that Pn of 1 equal to 1. So this becomes minus 2 times Pn dash 1 plus n into n plus 1 equal to 0. Therefore, Pn dash at 1 becomes equal to half of n into n plus 1. I hope that is clear. Now prove that all the roots of Pn of x are distinct. So Legendre polynomial యొక్క రూట్స్ మూలాలన్నీ కూడా వేరువేరుగా ఉంటుంది అని చెప్పండి. Let the roots of Pn of x equal to 0 are not distinct. మనం అన్ని వేరువేరుగా ఉంది అని చెప్పాలి. But we will assume that they are not distinct. That implies that at least two roots must be equal. So from the theory of equations, we get Pn of beta equal to 0 and Pn dash of beta is also equal to 0. Now Pn of x అనేది it is a solution of the Legendre equation. So we have 1 minus x square times Pn double dash x minus 2x Pn dash at x plus n into n plus 1 times Pn of x equal to 0. Now differentiating this r number of times using Leibniz's theorem, we obtain 1 minus x square times r plus second derivative of Pn of x minus 2x times r plus 1 times of r plus 1th derivative of Pn of x. Okay. And then minus of r into r minus 1 plus 2r minus n into n plus 1 times rth derivative of Pn of x equal to 0. Now what is going to happen? 1 minus x square r plus second derivative of Pn of x minus 2x into r plus 1 times r plus 1 the derivative of Pn of x minus of r into r minus 1 plus 2r minus n into n plus 1 times rth derivative of Pn of x equal to 0. Now in this equation, putting r equal to 0 and x is equal to beta, we get 1 minus x square times Pn double dash at beta, because the remaining terms Pn at beta is 0. Similarly, Pn dash at beta is also 0. So automatically this becomes Pn double dash at beta is also 0. Putting r is equal to 1 and x is equal to beta, we get 1 minus x square times Pn third derivative of the function of beta. It becomes equal to 0. That implies Pn third derivative of Pn at beta equal to 0. So ఈ విధంగా r equal to 2, 3, etc. n minus 2 పెట్టి and following the same procedure, we can see that the nth derivative of the function of beta is also 0. Okay. But now we know that what is Pn of x? It is a series expansion. What is it? It looks like 1 into 3 into 5, etc. 2n minus 1 divided by n factorial times. So x power n minus of n into n minus 1 divided by 2 into 2n minus 1 times x power n minus 2 plus n into n minus 1 into n minus 2 into n minus 3 divided by 2 times 2 into 4 into 2n minus 1 into 2n minus 3 times x to the power of n minus 4. Now this shows that the nth derivative of Pn of x is equal to 1 into 3 into 5 etc. 2n minus 1 divided by n factorial, which is not equal to 0 at x equal to beta. Thus, in one case, we get the nth derivative of the polynomial at x equal to beta is becoming 0. And in another case, it is not becoming 0. So the results are contradictory. Hence, we say that all the roots of Pn of x equal to 0 must be distinct. So finally, what are the learning objects that we are learning? Orthogonal properties. Using orthogonal properties, some problems. And we are going to find the generator of the Legendre polynomial. Okay. So these things we are going to learn. Now, orthogonal property of Legendre polynomials. If Pm of x and Pn of x are Legendre polynomials, m and n being positive integers, then integral -1 to 1 Pm of x into Pn of x dx equal to 0 if m is not equal to n, and that becomes equal to 2 by 2n plus 1 if m equal to n. Okay, that we are going to prove next time. Now, this Rodriguez formula we have covered in the last class. Do you like to have this Rodriguez formula? Those who are interested, they can ask me. We'll go further. Solution of differential equation. So for that, we consider 1 minus x square times d square y by dx square. Now, what is the differential? Legendre differential equation? 1 minus x square times d square y by dx square minus 2x into dy by dx plus n into n plus 1 times y equal to 0. Now, what is the coefficient of d square y by dx square? It is 1 minus x square. It should not be equal to 0 at x equal to 0. Now, we know that already we have started this kind of solutions. We consider the series solution y equal to, what is the series solution? A naught plus a1x plus a2x square plus a3x cube plus a4 x power 4 plus etc. ar x power r, ar plus 1 times x power r plus 1. So that is nothing but summation ar into x power r. Now what is dy by dx? A naught is a constant, so derivative of constant is 0. A1 comes at is 6. Derivative of x is 1. A2 times derivative of x square is equal to 2x plus a3 into derivative of x cube is 3x square plus etc. ar into r times x power r, so on. So here this becomes summation r running from 1 to infinity ar into r times x power r minus 1. Similarly, now once again differentiating with respect to x, we get d square y by dx square. What is the derivative of constant a1? 0. 2a2 constant comes out. Derivative of x becomes 1. So 3a3 and derivative of x square, what is it? It is 2x plus so on. ar into r minus 1 times x power r minus 2 plus 1. So we can summarize and we can write it in the simple form that summation ar into r times r minus 1 into x to the power of r minus 2. Now substituting all these values in 1, that is in the given Legendre differential equation, we are having 1 minus x square times second derivative. Summation r into r minus 1 times x power r minus 2 minus 2x into summation ar into r times x power r minus 1 r running from r to infinity plus n into n plus 1 into y. What is y? Summation r into x power r running from 0 to infinity. Now that implies summation r into r minus 1 x to the power of r minus 2 minus, if you multiply x with this, we get x to the power of r. So that becomes summation r into r minus 1 times x to the power of r. Okay. minus x squared into this. Okay, so we get first two terms. And the third term, take this x inside, that becomes minus 2 into summation r into x power r. And there is no change as it is, we are taking n into last term, n into n plus 1 times summation ar into x power r equal to 0. Now collecting the coefficient of x power r in the other equation and replacing r by r plus 2 in the first term. So what is going to happen? ar plus 2 into r plus 2 into r plus 2 minus 1 becomes r plus 1 minus ar into r into r minus 1 minus 2 ar into r plus n plus into n plus 1 into ar equal to 0. Now ar plus 2 into r plus 2 into r plus 1 equal to ar times r into r minus 1 plus 2ar into r minus n into n plus 1 into ar. Now ar plus 2 times r plus 2 into r plus 1 equal to ar into r minus 1 plus 2r minus n into n plus 1. That is nothing but ar into r square minus r plus 2r minus n into n plus 1. So ar into r square plus r plus n in minus n into n plus 1. Now what is ar plus 2? ar times n into n plus 1 minus r square minus r whole divided by r plus 2 into r plus 1 times ar. So taking minus sign, we get equation number 3. Now putting r equal to 0, 1, 2, 3, etc. We get, when r equal to 0, we get a2, that is minus n into n plus 1 minus 0 divided by 2 into 1. 0 plus 2 into 0 plus 1 times a naught, that is equal to minus n into n plus 1 divided by 2 times a naught. Now when r equal to 1, this becomes a3 equal to minus of n into n plus 1 minus 1 square minus 1 divided by 1 plus 2 into 1 plus 1 times a1, that is equal to minus n into n plus 1 minus 2 divided by 3 into 2 times a1. That is nothing but minus n square plus n minus 2 whole divided by 6 times a1. This can also be written as minus of n minus 1 into n plus 2 divided by 6 times a1. When r equal to 2, we get a4, that is equal to minus of n into n plus 1 minus 2 square minus 2. That is divided by 4 into 3. So times a2. So this is equal to minus of n into n plus 1 minus 6 divided by 12 times a2. So minus of n into n plus 1 minus 6 divided by 12 into what is a2? Just now we have calculated minus of n into n plus 1 by 2 times a naught. That becomes n into n plus 1 minus 6 by 12 into n into n plus 1 divided by 2 times a naught. And further simplification by taking LCM, 12 into 2, that is 24. The above equation becomes n square plus n minus 6 into n plus 1 by 24. So we can see that the product of this is nothing but n into n plus 1, n plus 2, n minus 3 by 24 times a naught. So in this way, we get the solution of the equations of the series. Now we are going to have another one. Pn at 0 is equal to 0 if n is odd. So that Pn at 0 equal to minus 1 to the power of n by 2 times n factorial divided by 2 power n times n by 2 factorial whole square when n is even. Okay. So we know that the generating function of the Legendre polynomial is summation t power n Pn of x equal to 1 minus 2xt plus t square whole to the power of minus r. Now putting x is equal to 0, we get summation t power n Pn at 0. So that becomes 1 plus t square whole to the power of minus r. So summation t power n Pn at 0 equal to, now what is the expansion of that? 1 minus power into variable. So 1 minus half into t square plus minus half into minus half minus 1 divided by 2 factorial times variable square. What is the variable now? T square. So on. This comes by the expansion of binomial theorem. That is equal to 1 minus half t square plus half into 3 by 2 by 2. So 3 by 4 times t power 4 minus etc. And we can easily see that alternatively we are getting plus minus plus minus plus minus. So we get minus 1 whole to the power of r. 1 into 3 into 5 etc. 2r minus 1 divided by 2 into 4 into 6 etc. 2n times t to the power of 2r. Now equating the coefficients of t power 2n on both sides, we get p to n at 0 equal to minus 1 power n 1 into 3 into 5 etc. 2n minus 1 divided by 2 into 4 into 6 etc. 2n. Okay, so minus 1 whole power n. Now multiplying and dividing both numerator and denominator by 2 into 4 into 6 etc. into 2n. Then automatically we can see that the numerator becomes 2n factorial and the denominator becomes 2 into 4 into 6 etc. into 2n whole square. So 2 can be written in the denominator 2 only. 4 can be written as 2 into 2. 6 can be written as 2 into 3. Similarly, 2n can be written as 2 into n. So from each term, if we take 2, 2, 2, 2, 2, 2, how many number of 2's are there? Terms of products n what? So 2 into 2 into 2 like that n number of times, that becomes 2 power n into 1 into 2 etc. into n whole square. That's why this becomes minus 1 power n into 2n factorial divided by 2 power n into 1 in n factorial whole square. That is 2 power n whole square becomes 2 power 2n n factorial whole square. Now equating the coefficients of t power 2n plus 1 on both sides, this becomes p 2n plus 1 at 0 equal to 0 because we don't get any odd terms on the right hand side. Only even terms are there. There are no odd terms. So p 2n plus 1 at 0 becomes equal to 0. I hope that is clear to all of you. Now, express 4x cubed plus 6x squared plus 7x plus 2 in terms of Legendre polynomials. We know by Rodrich's formula that Pn of x equal to what? 1 by 2 power n n factorial into nth derivative of x squared minus 1 whole power n. Now what is happening? Put n equal to 0, 1, 2, 3, etc. Thereby automatically already we have calculated and we have shown that P0 of x equal to 1, P1 of x equal to x, P2 of x equal to 1 by 2 times of 3x square minus 1. P3 of x equal to half into 5x cubed minus 3x. Now 4x cubed plus 6x square plus 7x plus 2 can be written as some constant terms of P3 of x, constant times of P2 of x, plus constant times of P1 of x, plus constant times of P0 of x we can write. So alpha times, what is P3 of x? We replace 1 by 2 into 5x cubed minus 3x, plus beta into replace P2 of x by 1 by 2 times 3x square minus 1, plus gamma times P1 of x is x, xi times P0 of x equal to 1. So this becomes now 5 alpha by 2 times x cubed minus 3 alpha by 2 times x plus 3 beta by 2 times x square minus beta by 2 plus gamma x plus xi. That is nothing but 5 alpha by 2 times x cubed, and then collect x square term. Now where is x? 3 beta by 3 times x square. Now two terms are there, two x terms are there. So combine them. Gamma minus 3 by 2 alpha times x. And without any x, there is a constant term, xi minus beta by 2. Now equating the coefficients of x cube, x square, x and x power 0, we get 5 alpha by 2 equal to 4 on the left hand side. So alpha becomes 8 by 5. Similarly, 3 beta by 2, that is x square coefficient. What is x square coefficient on the left hand side? It is 6. So 3 beta by 2 equal to 6. That implies beta equal to 4. Next, another one. Gamma minus 3 by 2 times of alpha equal to what? 7. So here we can see that gamma equal to 7 plus 3 by 2 times of alpha. That is 7 plus 3 by 2 times of 8 by 5. That is 7 plus 12 by 5. Therefore, gamma equal to what? 47 by 5. Now, similarly, we compare the coefficients of constant terms. Xi minus beta by 2 equal to 2. Therefore, xi equal to alpha plus beta by 2. Sorry, 2 plus beta by 2. So, when you take common 4 plus beta by 2, that is 4 plus 4 by 2, that is equal to 4. Xi equal to 4. So, from the given equation, we can write this as 4 by 5 times of P3 of x plus 4 times of P2x plus 47 by 5 times of P1 of x plus 4 P0 of x. I hope that is clear to one and all. Once again, please join with the above.